Hey everyone, this is Shipei. So in this video, I will show you how to use Tracker, the software that we are using in our lab to analyze the behavioral recordings from our zebrafish training experiment. After each experiment, the full recording will be approximately 3 hours long. The experiment is divided into 3 major periods: the 24 minutes baseline period, 3 minutes training period, and 153 minutes analysis period. However, for our data analysis, only a few short clips from the full recording are needed. Because importing a 3 hours video directly into the tracker can be very slow, and it will just take forever to import the 3 hours video into the software, the first step that you need to do after you got the recording is to cut the full recording into smaller video segments. The main time points that we are interested in are T0, T1, T2, T3, T4, and T5, which are used to evaluate the zebrafish performance after the training. In addition, the clips from 6 to 8 minutes and the 15 to 16 minutes will be also used as the baseline reference. Here's how we assign score based on the fish's performance. Its performance was quantified based on the fish's spatial preference relative to the illuminated checkboard stimuli. During both the baseline and the post-training analysis period, a score of +1 was assigned when the fish occupied the dark region of the arena, and the score of -1 was assigned when the fish occupied the illuminated checkboard region. The average score across each analysis window was then used as the performance index, or PI for abbreviation, with higher values indicating stronger avoidance of the illuminated area. The central hypothesis is that zebrafish will acquire conditioned avoidance after the training by associating the illuminated checkboard pattern with the electric shocks. So if learning occurs, fish are expected to avoid the checkboard region and spend more time in the dark region during the post-training analysis period. Therefore, an increase in performance index after training would suggest that successful conditioned learning has occurred, and we will do a paired t-test to compare their performance indexes before and after the training for the same individual fish. To download the software that we are using for our data analysis work, you need to Google Tracker Video Analysis and Modeling Tool, and then you need to click on the first link that appears on this page. It will navigate you to their main page. After that, you can click on the Windows option if you are a Windows user. They also have like Mac system option for Mac users. Just choose the one that your laptops are compatible with. Once you downloaded the software, here is how to import the video. Click on the Files tab and then Import, and then click on Videos. Go to the directory where you store your videos, and then click on Import. This may take a few minutes, so just wait before the video being imported into the software. Here I speed it up so that we can save some time. Alright, so once you have your video loaded into the software, the first thing you're gonna do is to set up the coordinate system. Click on the coordinate system icon and then move the center of the coordinate to the point that you want. You can put it here, or you can move it to the top of this arena. And then you need to define what object you want to keep track of. Click on point mass, and then you will create a new object for mass A. However, we don't want the name mass A for that object. So here you just change its name to, so for example, this one is sample, um, this is a sample demo that I used for this tutorial. And then you have to name, because we have like two fishes in this arena. You also want to distinguish the top one from the bottom one. So I will also put maybe a top um, here to distinguish them. When you are creating names for these objects, you want your name to be more specific. For example, test A, test with a number to keep the data more straightforward so that we can do data analysis more easily later. And then we need to click on this calibration stick. We need to put the stick from, this stick will measure what's the real distance, like in our real world. So if we are measuring the half length of the arena, it will be 9.6 centimeter, and then we convert it into meter. So the real distance will be 0.096. All right, looks good. So we're gonna move to the next step, which is to change the frames that the computer is analyzing per second. The original video that the default setting is 30 frames per second. So here we also want to change it to 30 frames per second so that every second we only need one number, like one index, one score for to evaluate their performance. If your video is 60 frames per second, then you need to change the number to 60. Oops, I misclicked on this. So remember, this is a calibration stick. You need to put it here to measure the real distance. And also one thing to remember, you don't want the coordinate system has angle with this calibration stick. You want the angle to be 0 so that it's totally, horizontally measure the distance, the horizontal distance. So if the angle is not 0, then you need to adjust your calibration stick and also adjust your coordinate system to make them, have an angle of 0 in between. And you cannot just click on the angle number to change its value because that is not going to work. So you need some time to do the calibrations. Then you can click on the zebrafish to define its position. So here's how we're gonna do it. You need to press Shift and then at the same time you click on the fish's position. Then you will mark its position and the system, so the software will automatically, store the value. When you successfully mark its position, the software will, automatically move to the next frame, and then you just do it again to mark its position. Just one more time, click on their position, and then the computer will store this value again, and then you just move to the next one and keep doing this again and again. So in this tutorial, I speed this process up because I want to save some time in the tutorial video. However, when you are doing this, you have to be very patient and very carefully to get a better accuracy, to improve the accuracy of our data. When it comes to the point where the LED pattern just switched, that's the point that I need you to pay attention to, because I need you to record this frame number. It's 120 in this example. And this number is important because we are going to use it in our code, which I will explain later. Here's another point that I need to highlight a little bit. So when you are setting up your coordinate system, you don't want the y-axis to cut exactly at the edge because the radiation of the light, as you can see here, if I move it to the left, then your coordinate is not accurately capturing the boundary of this LED that is being lighted up because of the radiation of the light. You cannot place it like right on the edge. You have to cross over the edge a little bit so that you can cancel out some of the effect of the radiation. And it's common that you mark it too fast and then you make a mistake. And if you made a mistake, you can go back to the frame by right-clicking on this frame and then choose go back to step 118, for example, and then it will navigate you back to that frame and override the wrong position. So you will use the same thing, shift and then left click on this position that will override the wrong position data. Remember, whenever there is a pattern switch, you need to record that frame at which the pattern switch, because that's the frame that we are going to use in our data, in our code. You need to pay really extra attention to this. Here I will speed up this process again so that we can save some time in this tutorial. Alright, so here we are done with the fish on the top. And remember, we have two fishes in our one arena, right? So we need to create another track data for the fish on the bottom. So here we need to click on this new and then create a point mask for the fish at the bottom. And then we also need to name the fish. So here, for example, test a button, and then you need to click on the button and then do the same thing for the second fish. And you need to start this frame from frame 0 so that it can move like all the way down to the last frame. And here I'm going to speed up this process again. Alright, so when you are done with all the data acquisition, now we need to export the data. Click on the file and then export data. So you need to select which data you want to export. So here we're gonna start with the top one. And the y-axis data is not that important for our data analysis. You can choose not to select it, or you can select it as well. It doesn't matter that much. We only need the x-axis data. So once you are done the selection, you give a name to this file, putting it into the right directory, and that's all. You need to do the same thing for the bottom fish as well. Okay, click on save. And do the same thing for the bottom one. Save them. Add the same directory and change the name of the file to bottom. And then click on save, and then you also need to save this tracker file. So when you close this window, it will remind you to save that, and then just click on yes to save this tracker file at the same directory. And then you need to change these two data that you stored for these two fish into a CSV file, and then use the code to compute their performance index. That's all for this tutorial. Thank you for your listening.